Imagine this. You wake up, rush through your morning, drink nothing, and by noon, you feel a little slow, a little tired, a little foggy. But here's the real twist. Your body has already started emergency protocols, the same survival systems it would use if you were stranded in a desert. So what is actually happening inside you? Why does something as simple as not drinking enough trigger such a massive internal response? Let's open the hood and look at the engineering of dehydration. Your body is mostly water, about 60% of your weight. But that water isn't just around. It's organized into zones, like a carefully designed fluid network. Two big compartments run the show. Inside your cells, the intracellular fluid. Around your cells and in your blood, the extracellular fluid. Each compartment needs just the right amount of water and electrolytes. If the balance shifts, even a little, your cells and organs feel it instantly. This is why dehydration is never just thirst. It's an engineering problem inside your body. The moment you start losing water through sweat, breathing, urination, or fever, your blood volume drops. Sensors in your carotid arteries, aortic arch, and kidneys begin firing alarms. They tell your brain, pressure is falling, we're losing fluid, activate survival mode. And survival mode hits fast. First, your nervous system kicks in. Your heart speeds up. Your blood vessels tighten. Your body is trying to keep enough pressure to supply the brain and heart. Next, your kidneys go into conservation mode. They reduce filtration. Urine becomes darker and smaller in volume. But the strongest response comes from hormones, especially ADH, renin, and aldosterone. ADA tells your kidneys, save every drop of water you can. Renin starts a chain reaction that raises blood pressure. Aldosterone forces your kidneys to keep sodium, so water stays inside your bloodstream. This is why dehydration makes your body feel tense, hot, and drained. Your internal systems are all fighting to hold on to fluid. If dehydration gets worse, the chemistry of your blood changes. The salt concentration rises, the osmolality goes up. And now something dangerous happens. Water starts leaving your cells, especially brain cells. Your neurons begin to shrink. This is why you feel headaches, irritability, mental fog, poor focus, slower reaction time. Your brain actually pulls away from the inside of your skull. The tension you feel is real. If dehydration goes the opposite direction, when you lose salt faster than water, your cells swell instead. And swelling in the brain can trigger seizures or coma. This is why dehydration is so risky. As water loss continues, your heart works harder. It pumps faster to keep blood pressure stable. Your kidneys struggle. They can't filter properly. Waste builds up in the blood. This is called prerenal azotemia, the early stage of kidney injury. Your muscles lose efficiency. Electrolyte shifts cause cramping, weakness, and sometimes dangerous arrhythmias. Your gut slows down. It doesn't get enough blood, so digestion becomes sluggish. Your temperature rises. You can't sweat properly, so your body overheats. Even a 1 to 2% loss of body water hurts cognition. At 5 to 10%, you start entering serious danger. Above 10%, shock, organ failure, and death become real risks. When dehydration is severe, your body leaves clues. Dark urine, fast heart rate, low blood pressure, high blood sodium, high blood osmolality, rising BUN creatinine, lactic acid buildup. These numbers show that organs are struggling, especially the kidneys and brain. Here's the good news. Once you start rehydrating, the same systems that activated to save you now help you recover. ADH levels drop, blood volume rises, cells rehydrate, the kidneys flush out waste, heart rate stabilizes, cognition returns to normal. But here's the important part. Rehydration must respect chemistry. If you fix sodium too fast, you can cause brain swelling or nerve damage. That's why electrolyte balance matters more than simply drinking water. Real recovery is about restoring the correct balance, not just drinking until you feel full. So what really happens when you're dehydrated? Your body runs a complex emergency protocol, one involving the heart, kidneys, brain, hormones, and cellular chemistry. It's not just dryness. It's a full-body crisis, even at low levels. And the moment you drink the right fluid, you're not just quenching thirst, you're letting your entire internal system stand down.